When you hear the term full-stack systems, it might sound like technical jargon reserved for seasoned developers, but at its core, the concept is straightforward and surprisingly intuitive. Imagine building a house. You need someone to design the facade, another to handle the structure, someone for the plumbing, and someone else for the wiring. Now, picture a person who can do all of these jobs, weaving every piece together into a cohesive home. In software development, a full-stack developer plays a similar role, an architect and a builder who understands and creates every layer of a digital application. So, what does full-stack really mean in the context of software? Essentially, being full-stack means working on every part of a project, the front end, the back end, and the integration that connects them. Full-stack development involves crafting both the parts users see and interact with, the front end, and the parts working behind the scenes, the back end. Any software application, whether it is a social media platform or an e-commerce website, is built on these two essential layers. The front end is the user interface, all the visuals, buttons, and forms that people engage with directly. The back end, on the other hand, is where the magic happens out of sight. The business logic, data processing, and communication with databases and other external systems. Developers who focus solely on the front end might use technologies like HTML, CSS, and JavaScript, often working with frameworks such as React, Angular, or Vue.js. Their expertise lies in shaping the user experience, ensuring that interfaces are both intuitive and visually appealing. Back-end developers, meanwhile, thrive in the world of servers, databases, and application logic, using languages and frameworks like Node.js, Python, Ruby, or PHP, and managing data with systems like MySQL, MongoDB, or PostgreSQL. A full-stack developer, however, bridges both these worlds. They can design and build the interface, write the code that powers the site's logic, connect to databases, and ensure all these pieces work together smoothly. Their adaptability streamlines the development process, enabling a single developer or a small team to oversee an entire project from inception to deployment. This holistic understanding allows for more efficient collaboration and often leads to faster project turnaround. Full-stack development is not just a collection of technical skills, it is a mindset. It requires proficiency in a wide range of programming languages, frameworks, and tools. Full-stack developers can manage everything from user interface design to server configuration and database management. They often play an integral role in building and maintaining web services and interfaces, developing new product features, performing tests, troubleshooting issues, and collaborating with other departments as needed. There are several popular technology stacks, combinations of tools and frameworks that full-stack developers might use. For example, the LAMP stack includes Linux, Apache, MySQL, and PHP. The MEAN stack combines MongoDB, Express.js, Angular, and Node.js. Each stack serves as a set of building blocks, providing a standardized way to develop robust applications. Regardless of the stack, the principle remains the same, integrating both the front end and back end to deliver a seamless experience for users. The benefits of full-stack development are significant, especially for startups and small teams. With a full-stack developer, a company can reduce the number of hires, streamline collaboration, and keep communication tight. This approach is also cost-effective and aligns well with Agile and DevOps methodologies, which value rapid prototyping, flexibility, and responsiveness to user feedback. Even in larger organizations, those who understand how the front end, back end, database, and infrastructure fit together are highly valued. Full-stack thinking often makes specialists better at their own roles by giving them a broader understanding of how their work fits into the bigger picture. Of course, there are challenges as well. The breadth of knowledge required can be daunting, and the complexity of managing multiple layers means that a full-stack developer must be careful to avoid mistakes that might arise from spreading themselves too thin. There is also a risk of relying too much on individual skills, which can affect the quality or scalability of a project. Yet, the importance of integrating front-end and back-end layers cannot be overstated. A cohesive application is more than just a sum of its parts. It is a system where every layer communicates smoothly, where user actions translate into meaningful results, and where data flows securely and efficiently. Full-stack systems are the foundation for much of the modern web, and understanding their structure is the first step toward mastering the art and science of software development. When you open a website and admire its crisp layout, smooth animations, and intuitive design, you are engaging with the front-end layer of a full-stack system, the part crafted for your eyes and fingertips. This is the code that runs in your browser, transforming static designs into interactive experiences. Front-end development centers on the user, building with HTML, styling with CSS, and adding interactivity through JavaScript. It is a world of color palettes, clickable buttons, smooth transitions, and thoughtful accessibility features. To make this process seamless and efficient, developers often use a suite of tools and frameworks. Bootstrap, for example, provides a collection of pre-built design elements, making it easier to create responsive, user-friendly interfaces. Modern front-end frameworks like React, AngularJS, Vue.js, Ember.js, and newer options such as Next.js and Quick offer structure and reusable components, allowing developers to build complex interfaces without starting from scratch each time. But the magic does not end with what you see. Beneath these polished surfaces lies the back end, the unseen engine room of any full-stack system. The back end is where requests from the front end are received and processed, where data is managed, and where business logic unfolds. This layer is typically built with languages such as Python, Node.js, PHP, Go, or Rust, each offering unique advantages in speed, scalability, and security. Frameworks like Express.js or Ruby on Rails help organize server-side code, manage routing, and handle the details of connecting to databases. It is the back end that ensures your login works, your shopping cart remembers its contents, and your saved preferences appear every time you return. While front-end development leans into creativity and design, the back end is often described as more technical, a world of logic, security, and data processing. At the heart of many interactions between these layers sits the database. Think of it as the application's memory, the place where all important information resides. Whether it is a list of users, product details, or a history of messages, databases such as SQL or MongoDB are designed to store, retrieve, and organize data efficiently. When you submit a form or make a purchase, the front end sends this data to the back end. The back end then acts as a mediator, communicating with the database to fetch or update information before sending a response back to the front end. This ongoing dialogue between layers gives applications their dynamic, interactive nature. The glue that binds these layers together often comes in the form of APIs and middleware. APIs, or application programming interfaces, are standardized sets of rules and protocols. They define how the front end communicates with the back end, and how the back end, in turn, interacts with databases or third-party services. APIs make it possible for a button click on the front end to trigger a flurry of activity behind the scenes, whether it is fetching weather data, updating a profile, or processing a payment. Middleware serves as an intermediary, handling tasks like authentication, logging, or transforming data before it reaches its destination. This orchestration of front-end, back-end, and database layers connected through APIs and middleware is what makes a full-stack system function. Each layer has its own technologies, best practices, and challenges. Front-end developers focus on making the interface visually appealing, accessible, and responsive across devices and browsers. They use tools like Node.js, not only for running JavaScript on servers, but also for managing dependencies and automating repetitive tasks during development. Back-end developers, meanwhile, ensure the application is robust, secure, and scalable, keeping data flowing smoothly and reliably. Modern full-stack systems thrive when these layers work in harmony. The front end and back end are in constant conversation, with the back end serving as the bridge to the vast stores of data in the database. This interplay is powered by a mosaic of programming languages and frameworks. JavaScript, Python, SQL, and TypeScript are among the most popular, according to the 2024 Stack Overflow Developer Survey. Frameworks and libraries act as toolboxes, offering structure and ready-to-use components that speed up development and help teams manage complexity. In essence, the architectural layers of a full-stack system are like the different sections of a well-rehearsed orchestra. Each has its own role, its own instruments and techniques, but together they create a seamless, responsive experience for users. Understanding how these layers interact and the technologies that connect them is foundational for anyone aspiring to master the art of full-stack development. Imagine for a moment the intricate choreography unfolding behind the scenes every time you tap a button on your favorite application or website. That single action sets off a cascade of interactions between different technological layers, each with its own language and responsibilities, all working together to deliver a seamless experience. At the heart of this collaboration are the mechanisms that allow the layers of a full-stack system to communicate, mechanisms that transform user intent into meaningful, reliable action. In the modern web, RESTful application programming interfaces are the most popular bridge between front-end and back-end. When a user interacts with a page, let's say by submitting a form, The front end crafts a hypertext transfer protocol request and sends it to a predefined endpoint exposed by the back end. This request, carrying data and instructions, travels over the internet, and the back end responds with the necessary information or confirmation. REST, which stands for Representational State Transfer, relies on a set of constraints that promote statelessness, scalability, and streamlined communication. Each endpoint serves as a doorway to specific resources or services, and standard hypertext transfer protocol methods like GET, POST, PUN, delete define exactly how to interact with those resources. For real-time updates, technologies such as WebSockets enable persistent bidirectional communication between the front end and back end. Structured data must travel from one layer to another in a way both sides understand. This is where data serialization comes in. Serialization is the process of converting complex, in-memory data into a format suitable for transmission or storage. For RESTful application programming interfaces and browser communication, JavaScript object notation has become the de facto standard, a lightweight, text-based format that uses key-value pairs. Its popularity comes from its simplicity and human readability, making debugging and development more approachable. But JavaScript object notation is not alone. Extensible markup language, comma-separated values, YAML, ain't markup language, and binary formats such as protocol buffers and message pack also serve as alternatives, each with its own strengths. Comma-separated values is often used for bulk data transfers, while formats like protocol buffers and message pack excel in high-performance scenarios where efficiency is critical. The choice of serialization format can impact speed, compatibility, and data integrity, so it is selected carefully to match the needs of the system. Of course, sending data back and forth across the internet raises important security questions. Before a user or service is granted access to sensitive resources, authentication acts as the digital gatekeeper. Authentication is the process of verifying identity, ensuring that the person, device, or system requesting access is authorized to do so. Modern applications use a layered strategy for authentication, often combining methods like OAuth 2.0, application programming interface keys, JSON web tokens, and even mutual transport layer security for especially sensitive operations. Each method has its place. Application programming interface keys might be suitable for internal communication, while OAuth or JSON web tokens provide more robust and flexible frameworks for user-facing services. These techniques, along with best practices like password hashing, rate limiting, and account lockout, form the first line of defense against unauthorized access. The story does not end with simply passing requests back and forth. Between the front end and back end lies a crucial, often invisible layer, middleware. Middleware acts as translator, orchestrator, and gatekeeper for data as it flows through the system. Imagine middleware as a diligent waiter in a restaurant, expertly taking an order from a diner, translating it for the kitchen, and managing dietary restrictions or special requests along the way. Middleware functions can handle authentication, log requests, validate inputs, and transform or format data before it reaches its final destination. In more complex architectures, middleware integrates diverse technologies, routes information based on business rules, and helps maintain data consistency by ensuring that data is correctly mapped and formatted between systems. Without middleware, many applications would struggle to bridge differences in technology, protocol, or data structure, making integration far more error-prone. Consistency in data is another thread running through these integrations. When a piece of information changes, say, a user updates their profile, data consistency ensures that the update is reflected everywhere that information appears, across databases, tables, or even different services. Achieving this level of reliability is foundational for accurate analytics and sound decision-making. In the world of full-stack development, tools like GraphQL and TypeScript are increasingly used to promote consistent data structures and contracts between the front end and back end, reducing the risk of miscommunication or mismatched expectations. Finally, best practices in integrating these layers emphasize not just technical efficiency, but also reliability and maintainability. It is about building systems where each layer communicates clearly, securely, and predictably, using well-defined contracts and robust error handling. This careful integration is what allows a full-stack application to respond instantly to a user's action, update data in real time, and maintain the trustworthiness that users have come to expect. In every robust full-stack system, the interplay between APIs, serialization formats, authentication mechanisms, and middleware is what makes seamless, secure, and reliable communication possible. These components, working in harmony, transform a collection of distinct technologies into a unified experience, One where the boundaries between layers all but disappear for the end user, even as the underlying system maintains precision, security, and consistency at every turn. The journey from a fresh idea to a fully deployed full-stack application is rarely straightforward. It is a process shaped by careful planning, collaboration, and a series of practical decisions that ensure every part of the system, no matter how complex, works together seamlessly. At the heart of this process is a workflow that balances creativity with discipline, making sure both the user-facing front-end and the data-driven back-end are developed, integrated, and maintained with precision. For large-scale projects, developers might choose to focus on building out either the front end or the back end first, depending on the team's strengths or the project's immediate needs. However, in full-stack development, the ultimate goal is always integration. The two halves must come together, each influencing the other's design and function until they form a cohesive whole. This iterative integration is crucial as it allows issues at the intersection of the two to be identified and resolved early rather than after months of isolated development. If there is a single tool that quietly enables this collaboration, it is version control. Modern version control systems are the backbone of software development, allowing teams to track every change, experiment without fear, and roll back mistakes when they inevitably occur. Best practices in version control call for small, frequent commits, each representing a logical unit of change. This approach makes it easier to identify the source of a bug or performance issue and streamlines collaboration. Each developer's contributions are clear and conflicts are more manageable. Maintaining a central repository is essential, ensuring everyone works from a single source of truth. Structured workflows, such as branching for new features or bug fixes, help organize the chaos that can emerge as teams grow and projects scale. But organizing code is only the beginning. Building robust full-stack applications means thinking beyond just getting things to work. Performance, scalability, security, maintainability, and user experience are always top of mind for experienced developers. To meet these demands, certain principles guide the development process. Component-based architecture encourages modularity, making code easier to maintain and extend. The DRY principle, do not repeat yourself, reminds developers to avoid duplicating code, reducing the risk of inconsistencies and errors. Test-driven development and scalable back-end design further ensure that the system can handle growth and adapt to changing needs, while security best practices are woven in from the start, not added on at the end. Testing, in all its forms, is essential to this process. No single strategy fits every project, but a balanced approach is widely considered best practice. Unit tests provide a safety net for business logic, catching errors at their source. Integration tests ensure that different parts of the system work together as intended, simulating real user flows. For critical user journeys, end-to-end tests offer another layer of assurance, checking that the user experience remains smooth from start to finish. Keeping these tests minimal and fast is important. Long-running tests can slow down development, especially in continuous integration pipelines, where code is built and tested automatically with each new commit. By focusing on unit and integration tests and ensuring they run as part of the continuous integration and continuous delivery process, teams catch problems early and often, reducing the risk of last-minute surprises. The testing landscape for full-stack applications is broad. There are front-end unit tests, integration tests, and end-to-end tests, each targeting a different aspect of the user interface. The back-end requires its own set of unit, integration, and performance tests, while databases are tested for reliability and consistency. Even the deployment process is scrutinized, with infrastructure and deployment tests ensuring the application runs as expected in its target environment. Continuous testing, embedded in the continuous integration and continuous delivery pipeline, forms the backbone of a reliable delivery process. Deployment is the final, critical step. Here, automation reigns supreme. Tools like Docker allow developers to package their applications and all necessary dependencies into containers, ensuring consistency across development, testing, and production environments. This containerization simplifies scaling and maintenance, and when paired with orchestration tools like Kubernetes, it enables the deployment of complex, distributed full-stack systems with confidence. Cloud platforms such as Amazon Web Services and Azure offer further options. With services like Amazon Web Services, Elastic Container Service, and Azure's Developer Command Line interface, developers can provision infrastructure as code, automate deployment, and host front-end and back-end services as distinct, scalable entities. Tools like Jenkins and Terraform can be woven into this process, orchestrating builds, managing infrastructure, and supporting continuous integration and deployment. Throughout the life cycle of a full-stack application, from its initial design to its deployment in the cloud, the process is one of continual iteration building, testing, refactoring, and scaling. Each stage is shaped by a focus on best practices, automation, and collaboration, ensuring that the final product is robust, maintainable, and ready to meet the needs of real users. The end-to-end journey is demanding, but for those who master it, the result is software that stands the test of time. Full-stack development continues to evolve at a rapid pace, and as we look to the near future, certain trends and best practices are emerging with remarkable clarity. Interestingly, even as many aspects of the field become more complex, web development in 2024 is showing signs of a return to simplicity. This does not mean discarding hard-won progress or advanced techniques. Rather, it reflects a maturing field that places greater value on maintainability, clarity, and the ability to scale applications with ease. Large-scale software projects are now being designed with evolving best practices in mind, making it possible for teams to build robust systems without getting lost in unnecessary complexity. One of the most significant shifts in recent years is the rise of serverless architecture. This approach allows developers to focus almost entirely on writing code, while cloud providers quietly manage the underlying infrastructure. There is no longer a need to worry about provisioning or maintaining servers, as the cloud platform handles scaling, reliability, and even cost optimization behind the scenes. Serverless architecture is built around key concepts such as function as a service and backend as a service, which let developers deploy small, independent functions or leverage ready-made backend services. The event-driven nature of serverless systems means that code runs only when needed, and the pay-as-you-go pricing model ensures you pay only for the resources you actually use. This shift has been transformative for full-stack developers, offering seamless scalability, reduced operational overhead, and significant cost savings. By abstracting away server management, serverless architecture empowers teams to innovate quickly and adapt applications to changing demands with minimal friction. As development workflows change, so do the technologies and tools that shape daily practice. Looking ahead to 2025 and beyond, the landscape of full-stack development is expected to be influenced by several key trends. The adoption of low-code and no-code platforms is increasing, enabling both developers and non-developers to build sophisticated applications with minimal hand-coding. Artificial intelligence and machine learning are becoming part of everyday development processes, sometimes even enhancing the workflow itself by speeding up code generation, testing, or deployment. Blockchain is appearing in more use cases, especially where trust and transparency are crucial. Cloud computing continues to underpin much of full-stack development, offering flexible resources and powerful new services. Meanwhile, fields like data science, cybersecurity, DevOps, augmented reality, virtual reality, and the rise of progressive web apps all contribute to a rapidly diversifying toolkit for the modern developer. Hybrid stacks, where multiple frameworks and technologies are combined to suit the specific needs of a project, are also emerging as a trend. With these new capabilities come new responsibilities, especially regarding security and scalability. Security remains a constant concern, and best practices for full-stack developers are as vital as ever. It is essential to sanitize and validate every piece of user input, ensuring that malicious data cannot slip through to sensitive layers of the application. Proper authentication and authorization mechanisms must be in place to guarantee that users can only access resources and functionality appropriate to their roles. Preventing common vulnerabilities, such as cross-site scripting and SQL injection, requires vigilance and a proactive mindset. As applications become more distributed and interconnected, the potential attack surface grows, making it imperative to build security into every layer rather than treating it as an afterthought. Scalability is another area where best practices are evolving. The trend is toward modular architecture, such as microservices, where applications are broken down into smaller, independent components that can be deployed, scaled, or updated individually. Standardized application programming interfaces enable these components to communicate efficiently and reliably, while caching and load balancing help distribute traffic and reduce bottlenecks. Cloud-native solutions make it easier to scale applications up or down in response to real-world usage patterns, and continuous integration and deployment pipelines ensure that changes can be tested and delivered rapidly without interrupting service. Building scalable and secure applications requires a thoughtful blend of these strategies. Embracing microservices allows teams to respond quickly to new requirements or changes in usage. Leveraging cloud-native solutions ensures that infrastructure can grow alongside the business. Secure authentication and authorization protect users and data, while continuous integration and deployment pipelines provide a framework for continuous improvement. These best practices are not simply a checklist, but represent a mindset, a commitment to building systems that are robust, flexible, and prepared for both challenges and opportunities. The pace of change in full-stack development means that continuous learning is not just recommended but necessary. Staying informed about industry trends, regularly assessing your own skills, and identifying knowledge gaps are all strategies that help developers remain relevant and competitive. Setting clear learning goals, whether it is mastering a new framework, exploring artificial intelligence tools, or deepening expertise in security, ensures that growth is intentional rather than haphazard. Career development in this field offers multiple paths, from specializing in either front-end or back-end technologies to stepping into leadership or architecture roles. Each path brings its own challenges and rewards, and the best choice depends on individual interests and long-term aspirations. Ultimately, the evolving trends and best practices in full-stack development are reshaping what it means to build software for the modern web. The future promises even more powerful tools, smarter automation, and new ways of working that prioritize both simplicity and sophistication. By embracing continuous learning and focusing on security, scalability, and adaptability, today's full-stack developers are well-positioned to thrive in a dynamic and ever-changing landscape.